All right, thanks everyone. Yeah, my name is Bryan, and today I'm going to talk about TypeScript. I work at Microsoft, and I use TypeScript every day there. I write TypeScript for Node.js, well, a combination of Node and the web. But I'm actually kind of new to it. I first started using it in around February or so. So I'm like definitely intermediate level, not quite advanced yet. But I've learned a lot along the way. So I kind of want to talk about what TypeScript is and how to use it really well with Node. But first, let's talk about what is TypeScript. TypeScript is a statically typed variant of JavaScript. It's a compiled to a language like a lot of others out there. The big thing it has is static typing. This is sort of the key feature of TypeScript that makes it different from vanilla JavaScript. For those of you who don't know what static typing is or come from a pure JavaScript background, static typing basically just means that whenever we create a variable, there is a type that is associated with that variable, a string, number, boolean, something like that. And once that variable has a type, that type can never be changed. Once it's a number, it will always have to be some number. And then everything else is sort of just built on top of this basic concept. TypeScript also has the concept of classes and interfaces, very similar to C# and Java if you come from those worlds. There's a module system, and as I mentioned, it compiles straight to vanilla JavaScript. So looking at just a little bit of basic TypeScript, here we see how type declarations work within TypeScript. We have a simple function, combine names. It takes two arguments, first and last, and we'll combine them together. There's a couple of decorations that we see on this compared to usual JavaScript, though. After each argument, you see that there's a colon, and then there's a type. So what this says is that first and last are both strings. And then after the closing parentheses of the function arguments, there's another colon and string, and that part means that the return type of this function is also a string. And so what this does is once we have this, then every time this function is called, it has to be passed those types of arguments. And if you try to pass it anything else that's not a string into either of these parameters, we'll actually get a compile time error. So after this function, we create two variables, first name and last name. We say that these are also strings, and we assign them Philip and Frey. So then we can call this method and log it out, and everything is nice and happy. This compiles just fine. But let's say, for example, we did const last name colon space number equals 10. Then TypeScript would actually not even compile. So with static typing, instead of having a lot of errors happen at runtime, which is the typical JavaScript way, they move that to compile time. So before you even have to go and load the browser or run your app, you know that there's an issue. So extending on this is the concept of interfaces, which are pretty central in TypeScript. And an interface is basically a definition that says that objects of this interface type must conform to this contract. It's basically a contract for object layout. It says, here's the properties in it, and these are their types. So in this case, we have a person interface with first name, last name, which are strings, and then an age, which is a number. So then whenever we create a variable and we assign an object literal to it, we say that this variable Frey conforms to this contract person and that it has these types. And so when this happens, TypeScript will check and make sure that it has all of the properties listed in the interface, that they are the correct types, and that there are no extra properties either. It has to match that exactly. Extending on the concept of interfaces is classes. Classes in TypeScript you pretty much just take typical vanilla ES6 classes, and then we've added just a couple of things on top of that. For one thing, classes can implement interfaces. So we say in this case, ship implements iShip. And so what happens here is when we implement this class, TypeScript will make sure that all of the properties and method signatures from the interface exist in the class. But there is a little bit of a difference compared with object literals. In classes, you can add extra things that are not defined in the interface. The only thing is that the things in the interface must be in the class. There's another little thing going on here, though. You see this public and private kind of keyword going on. So this is another idea that comes from C++, C#, Java, all those languages. And the concept of this is this modifier in front of a method or variable says what the access level is for that property. Public means anyone can access it, and basically public acts like a standard JavaScript object property. If that property is there, anyone can see it, anyone can access it. If it's private, though, this actually means that only the class itself can access that variable. It's private. Think of this as the equivalent of like underscore variables in vanilla JavaScript. But it actually does a little better than underscore variables because under the hood, it uses symbols, which is another new ES6 feature. And with that, it means it's actually impossible for someone else to get access to this property. There's no like funky hidden name or anything. It's like genuinely hidden. And so this is great for hiding implementation details and things like that. Moving on to modules. So actually, TypeScript just uses ES6 modules. There's really nothing new on top of that, with one slight exception, and that is that we can also import interfaces via modules. So a thing about an interface that's a little interesting is that it's not actually a value. Unlike everything in JavaScript, an interface is just this contract. There's no like value inside of V8 when it's running and things like that. But other than that, it's just standard ES6 modules, import, export, all that kind of good stuff. And so like these are the core features in TypeScript. There's a whole bunch of other like details of the language and like small features and things, a lot of which are really useful. But like I find these are sort of the core things that I use all the time. So why are these things great? Why does this make TypeScript a compelling language? Well, the biggest thing is type safety. And what type safety means is just we get a lot of guarantees about types. It basically helps us catch errors. The biggest area where I found that it's helpful is that it reduces typos. If we think in JavaScript, how many times have we been trying to reference a property on an object, and we end up mistyping the name of that property? We just leave a letter off or something like that, and we don't notice it. And then we go and we run our code, and we hope that we get a really nasty like exception thrown, but sometimes that doesn't happen. Sometimes we get undefined instead of 0, and that's not very obvious in logic. But with TypeScript, this is always caught by the compiler at compile time. Like we're guaranteed to know that there's a problem instead of hoping that we find it at runtime. And the sort of going on for this is that it really reduces the chance of making a mistake when refactoring, especially when it comes to, once again, properties on objects. In vanilla JavaScript, if we want to rename a property name on an object, typically we have to go through and grep the code base, and we have to like sort of look at each line and say, oh, is this actually that property, or is this other thing? It's kind of an intensive process. And so in JavaScript, we tend to just try and avoid refactoring when possible. In fact, I would say that's sort of a best practice, just because there's a risk. But in TypeScript, because this is all typed ahead of time, we can actually refactor with a lot of confidence. When we rename it, we can know for certain if we have renamed every single instance of that. In fact, a lot of tooling built on top of TypeScript can even basically refactor things for us. We basically right-click on a variable or something like that and say rename, enter new name in TypeScript and Visual Studio Code, and other editors can just rename it all for us. And we have complete confidence that this was done correctly. So here's a screenshot of Visual Studio Code. Visual Studio Code is a lightweight editor from Microsoft. It's built on top of Electron Shell, the same as Atom and a few other editors available on all platforms. And this is kind of what the refactor looks like. You basically hit F2, saying, I want to rename this, enter in the new name, and it will search not only within the current file, but every single file all across your project. It'll look for all the other files that import this module, and it will rename it all for you. And it's 100% accurate every time, too, because, once again, static typing. So TypeScript is great for a lot of projects. I think most projects can benefit from using TypeScript, at least a little, but it definitely has some cases where it really shines, where the benefits become really obvious and really helpful. The first I would say is with large teams. There's a lot of people working on a single code base. In addition to just simply catching errors and things like that, it helps with discoverability and a few other things of that nature. We all kind of write classes that end up being used by other developers on our team and things like that. And in an ideal world, we're documenting everything, writing lots of comments and talking about what all the inputs and outputs are, but we all know that we don't really do that very often. And with TypeScript, it helps because it can be somewhat self-documenting, or at least partially. We want to use some method that someone else wrote and we know nothing about it. With TypeScript, usually I found I can just look at the signature, and with the name of the variable combined with the type, you can kind of figure out how to use it without having to go bug the person next to you who maybe out on vacation or something. I'd also say it's really helpful for larger projects. With large projects, refactoring becomes much, much more complex. The bigger the project, the harder a refactor is in regular JavaScript because the chance of errors increase. But because TypeScript is statically typed, when you refactor, you have that complete confidence. And so the larger the project gets, you don't get an increase in complexity of refactoring and maintenance and things like that. Another really ideal use case that I've seen in practice is, let's say you have a team that has written some backend, and it was written in Java or .NET or some sort of like old statically typed system. Maybe it's a legacy system, and you want to upgrade it to Node. Well, all your developers know Java or .NET or whatever is written in. And so for people coming from those languages that have to learn Node and JavaScript for the first time, TypeScript can make it a lot easier to transition because it's using a lot more of those old skills. So okay, I've talked about types and things like that. I want to dive into the type system a little bit because sometimes there can be some confusion around that. The key thing is that types in TypeScript are native JavaScript types. That's really what it is. There are 7 types in TypeScript, as there is in JavaScript. That is undefined, number, string, Boolean, object, function, and symbol. And that's it. There are no other types in TypeScript. A lot of other statically typed languages do have other types, like special types of numbers and stubbles and things like that. But TypeScript doesn't have those. It's like they're just straight up JavaScript types. And classes in TypeScript are just straight up standard JavaScript prototypal classes. TypeScript doesn't try and hide the fact that it's JavaScript. It really embraces it and tries to think, how would this statically typed feature look in JavaScript? What's the JavaScript way of doing that? And so another thing with types, kind of following along in this vein, is that types are opt-in. You don't have to type everything. So what this means is that vanilla JavaScript, a straight up regular old JavaScript, is actually valid TypeScript in most cases. And so this is great if you want to transition an existing code base. You can basically start by renaming the extension from js.ts, and you're kind of done. You can just sort of add types as you go over time. And the way it does this is if there's a type that it doesn't know what it is, it gives it a type of any. When a type is any, that means it can take any value on. It basically acts like a standard JavaScript variable. So it's kind of like a backwards compatibility thing. Now, one thing it does, and this is why I say if you just rename the extension, it almost always works, but not quite, is that TypeScript types are inferred when possible. So if we create a variable and we give it a type, x equals 10, well, we know that 10 is a number, right? So TypeScript's going to say, oh, I see you assigned a number. I'm going to go and set that type for you. And so this const x equals 10 basically turns into const x colon number equals 10. And this is really handy because it just reduces a lot of typing and things like that. And it actually helps TypeScript feel even more like just regular JavaScript. All right, so how to use TypeScript with Node? If any of you have looked at TypeScript in the past, more than about, say, 2 months ago, you might remember it being kind of difficult and kind of unwieldy. But we released TypeScript version 2 pretty recently, and it makes a lot of really nice improvements. And these days, it's actually really clean and simple. Basically this right here. So you start by installing the TypeScript compiler. You can do it globally or locally and have it run via npm run scripts or whatever else. And then we do this npm install -s save at types/node. And we'll go into this a little more what that means, but basically this sets up the sort of node bindings that we say this is a node project. And then finally we run the compiler, we give it this outdir flag, we give it a directory it's going to go to, and then the file that we're going to compile. But there's a lot more complicated configuration we can do if we want. You can do a tsconfig.json file. And this works a lot like the Babel config if you've ever used it before. There's all kinds of options. We can say, what sort of module system do we want to output files as, where, source map stuff, and what are the input files. TypeScript also has a linter. It's called tslint. It's really, really similar to ESLint. So if you've used ESLint before, then tslint is going to feel right at home. Like the way you configure variables, the types of things you configure, all pretty similar. So same thing, npm install g tslint, and tslint your files. I want to talk briefly about some ES6 considerations. So there is one slight difference with Babel. So if you're used to Babel, this is one thing to keep in mind, is that TypeScript does not ship with a runtime. There's no equivalent to Babel-runtime if you've used that. So what this means is that all of the ES6 and a lot of the ES7 syntax is handled by TypeScript, but the runtime operations are not. So things like object.assign, symbol, and things like that, those are not polyfilled by TypeScript. That was sort of an intentional choice to keep TypeScript small. So if you have to target older versions of Node, or if you're working in the browser, you might have to do something complicated. Usually the recommended way is to go TypeScript to ES6, which basically just strips off the types, and then use Babel to go the rest of the way and include the Babel runtime. Editors, we have really good support. Out of the box, both of the Visual Studio products have it. not surprising, I would have guessed. All the JetBrains IDEs have support out of the box, so WebStorm, PyCharm, IntelliJ, things like that. And then all the other major ones have support via a plugin, Sublime, Atom, Vim, Emacs. So whatever editor you're used to using, you can TypeScript to work with that editor. So that way you can just stick with your typical workflows. One of the big things that comes up is, okay, so you've got this great typed code, but what about all the other modules out there that are not written in TypeScript? Well, to work with those, we use these things called TypeScript definition files. And a definition file basically says that we're going to create this interface that's statically typed for this other external module. And yeah, it's not going to be exactly the same, because static code is, by definition, slightly more limited than dynamic code, but it's usually really, really close. And so one of these definition files is basically, it's a declaration without an implementation. And so it's a lot like C++ header files, if you've ever worked with C++. And they have a d.ts extension. So this is what it looks like. It says we're going to create this definition file for this module called Planet. It's going to have a couple of functions on it and an interface that gets exported. But you notice these have no implementation. It's just the signature. And that's enough for TypeScript to give you types and auto-completion and all that kind of great stuff. Which is awesome. It sucks if you have to write it for all the modules used, especially since modules use modules, use modules, use modules. So instead we have this concept of a global type definition file. And these are files that have been created, sometimes by Microsoft, sometimes by the community. We get contributions from everywhere. And it's basically definition files for all of the popular modules. They're stored in the types scope inside in NPM itself. And pretty much everything you use these days, that's at least reasonably popular, has a definition file. And so it basically just looks like this. You just do npm install --save at types/express. And once you run this command, you all of a sudden have these definition files for Express, which is awesome because you can get really, really good code completion, all sorts of things like that inside of your editor for Express. And so that makes it quite a bit easier to use. And that's kind of the key things about TypeScript. There's a whole lot more to the language. You can go to typescriptlang.org to learn more. But yeah, that's kind of the key things, and I think it's been a great language. And thank you very much.
So thank you, Bryan. Any questions from the public?
Got a couple quick minutes.
Please raise your hand.
Yeah, go ahead.
You have some. Give me. Please use this.
So from the command line, you can import the descriptions, like you said just now, to help with code completion. But doesn't that typically, an IDE do that as well out of the box? So why would you do that instead of just letting the IDE do it for you?
Well, this is, I should have clarified. So whenever you install these type definitions, it's to allow IDEs to do that. Whenever you install these, it allows it to do it much better. So let me get out of this real quick and just show what that's like. So whenever you do this auto-completion, instead of just getting, say, the name of it, you would actually get the name, and then you would also install Express real quick. You also get, okay, here's this function, and it'll show you, here's all of the parameters for this function, too, before you even start typing anything, which is really handy. So we would go in here, import star as Express. Make that a lot bigger. From Express. And then you could do, var app equals Express, right? And then app.get. You can see it's actually auto-completed all the information for the get property. And so that's what that type definition file does. And also if there's any JS.comments associated with that method, it'll also show those in the type completion here. So that's where it helps, is it gives more hints so you can get more intelligent auto-completion. Yeah.
Hi, so I'm a big fan of TypeScript, but unfortunately the rest of the people in my company ended up going with Flow. I was just wondering if there's any plans or any way to get TypeScript definition files working with Flow.
There's not any plans. I've seen some conversations happen around this both. I don't think I've seen them at Microsoft, but I've seen them outside. And there are a couple of things inside of both TypeScript and Flow that are different. and are like just fundamentally incompatible with each other, unfortunately. It mostly has to do with how like null types work. Null is like treated specially because null doesn't have an implicit type to it, and so like how do you handle null? Flow and TypeScript just have fundamentally different answers to this question, and so like the edge cases of these type definition files are just kind of incompatible because of it.
Here we have a last question.
What does the roadmap for TypeScript look like?
That is a good question. I don't know myself, but it's on the website. So I don't work on the TypeScript team. But yeah, I believe it's on the website, and you can also stop by the Microsoft booth later, and we should be able to figure that out for you.
Okay, thank you, Bryan.